Hey everyone, so today we're going to be doing question 18 of your textbook, chapter 13C, which is your static and dynamics chapter. This is the last question of the chapter, so it's tend to be the harder ones, and I thought might as well have a crack at it. So let's go. A particle of mass 5 kilograms is being pulled up a slope inclined at 30 degrees to the horizontal. Clearly you have a slope right there, and you have an object resting on the slope. The mass of the object is 5 kilograms. What I like to do is I draw the weight force from that object, which goes directly down. So weight force is 5 times gravity. So 5 is the mass, gravity G, mg. And let's see, inclined at the degrees, 30 degrees, right there. Okay, let's keep reading. The pulling force F newtons acts parallel to the slope, as does the resistance, with a magnitude of 1/5 of the magnitude of the normal reaction. So you have a force pulling it up the plane horizontal to the slope, and you have a resistance. So there is friction here. Resistance we know is 1/5, 1/5 of the magnitude of normal reaction. So basically Fr equals 1/5 of n. So mu is 1/5. Okay, so friction right here, and yes, we do have a normal force as well. Normal reaction force. The invisible force, the natural force that you should also draw, is your triangle right here, because it's on the inclined plane. So naturally it should be going down, and that angle is 30 degrees. Right, let's have a go at the question. A, find the value of F such that the acceleration is 1.5 meters per second squared up the slope. So question A, this is very typical, finding acceleration. So how do you do this? To find F, we want to solve for F, given acceleration is 1.5 meters per second squared. To do this, we use Newton's second law of motion, so resultant force equals mass times acceleration. To get our resultant forces, we look at all the forces going up and down the plane. Right, so let's have a look at the forces going up. You have F. Any other forces going up? None of it. So we look at the force going down. So going down, you can see that there's clearly friction, so you minus friction. And there's also another force going down, which is the natural force right here. And to solve for this, it's 5g, the weight force, times by sine of 30 degrees. So in this case, 5g times sine of 30, because opposite of 30 is that length right there. That's why you use sine. 5g times sine of 30 degrees. And you see no other forces going up and down the plane, and that's it. So you just let it equals to m times a. M is 5. A acceleration is 1.5, which is 3 on 2. Okay, so let's proceed to solve this equation. So we need to solve for F. Before we solve for F, we need to find what Fr is, the friction force. What is friction? Friction is 1/5 of the normal force, right? Over here, 1/5 of the normal force. How do you find the normal force? So to get the normal force, the normal reaction force, right here, you have to also find this force, the one opposite of it, so that the object doesn't fly up the plane. You know, it doesn't make sense for the object to move up or move through the ground, through the plane. It only slides along that slope right there. So how do you find your normal force? Normal force should equal whatever force this is. To find that force, it's 5g times cos of 30 degrees, because it's adjacent. So n equals to 5g times cos of 30 degrees. So cos of 30 should give you root 3 on 2, so it essentially is just 5g root 3 divided by 2. Okay, this is a calculator question, so you could easily just use a calculator as well. But I'll just keep moving along. So F, we're solving for F, minus our friction force, which is 1/5 times n. We have 1/5 times normal force, which is 5g, root 3 over 2. And we also have to minus 5g sine 30. Sine 30 degrees is half, so it's 5g over 2. And you let that equals to 15 divided by 2. 5 times 3 is 15. Okay, you pretty much got all your numbers already. You can easily solve for F in this case. You move 1/5 times 5g root 3 over 2. You move it 5g over 2 as well to the other side. And if you use your calculator, guys, you should get 40.49 Newton. and that's F. So if F is 40.9 Newton, then your object is moving up at an acceleration of 1.5 meters per second squared. Very simple. Okay, but the question that I want to go through is part B. Let's have a look at part B. Also, find the magnitude of the acceleration if this pulling force, so that F, 40.49, now acts at an angle of 30 degrees to the slope, i.e. at 60 degrees to the horizontal. What does that mean? So this F used to be parallel to your slope. So before that, it used to be parallel to the slope, but now we want to find the acceleration, so not 1.5 anymore, when the force is going this way. So 30 degrees to your slope, not just 30 degrees to the horizontal right here. It's 60 degrees in total, or 30 degrees to the horizontal and an additional 30 degrees to your slope. So I'm just going to redraw that again so that it looks clear. So you got your object, the weight force, which is 5g, and then you got your normal force as usual. There should always be normal force and weight force. And you got your pulling force, which is F, which is 40.49. So it's the given force here. Find the magnitude of acceleration if this pulling force, which is our 40.49, is 30 degrees, right? Okay, and of course you got friction going the other way, as we already had friction right here. And then you have the natural force moving the object downwards. Okay, that is 30 degrees, that slope is 30 degrees. Okay, how do you find your acceleration? So that is our goal. We need to find acceleration, our new acceleration, when the 40.49 is on an angle of 30 degrees to the slope. To do this, we use the same equation right here as before. So F, you have F, but it's not just F by itself, because F is no longer just going up the slope. It's going up the slope at 30 degrees. So instead of using F, because we need to resolve this direction, that direction, F is not going this direction, it's going up as well. So instead of just having F, you need to have F cos of 30 degrees. Because if you draw this triangle right here, guys, right there, then cos will give you this adjacent part. So that's why F cos 30 will give you this section going up the slope. F cos 30 degrees, and then we got nothing else going up, so the only other forces are going down, which in this case is friction. And you also have to minus the natural force going down, which is 5g sine 30, as we've done already. 5g sine 30 degrees, and that should equals to mass, which is 5 times acceleration. Acceleration is not 1.5, don't confuse that. It's a different acceleration. Okay, so we want to find what Fr is first. To find Fr, we need to find our normal, because Fr, as we know, is 1/5 of your normal. To find your normal force, it's slightly different from when we did over here. So normal force over here was just opposite of your natural force going down the slope. But in this case, our normal force also has an additional upward force as well. So you can't just have normal force equals the downward force. You must have normal force plus this force going up, because the object is also pulling it up, and we know this object cannot fly up the slope, right? It just has to slide across the slope. So because it's not going up or down, then that normal force plus your 40.49, so this upward force right here, 40.49, which is F, times by sine 30 degrees, because it's opposite, should equals to the downward force, which in this case, we have done that before, 5g cos 30 degrees. Once you do this, you can easily solve for normal force. In this case, I'll just leave it as it is first. So 5g cos 30 should be 5g root 3 over 2 minus 40.49 divided by 2. Okay, so once you get your normal force, you can bring it back into your friction and then chuck in all your values and solve for A. So let's have a go. We have F cos 30, which is 40.49 times 30 cos 30, which is root 3 on 2, minus friction. So friction is in this case 1/5 of our normal force, so I'll just write here 1/5. You should be doing this on your calculator. It will solve it quickly. So 5g root 3 over 2 minus 40.49 over 2 minus friction, and then we also have minus 5g sine 30, which is 5g divided by 2, because sine 30 is a half. And you let that equals to 5a. So to solve for a, you divide everything on the left hand side by 5, and your acceleration should be, in this case, 1.22 meters per second squared. So that's how you do this question, question 18. So for part B, your force is not parallel to the slope anymore, it's going 30 degrees to the slopes. So that means your normal force isn't just by itself, it also has the upward force, and added to that should equals to this downwards force. And that's it. So the difference here is your normal is a bit different, so friction is different as well. Right, so that's how you do question 18, guys. If you have any questions, just leave a comment and that'll be great. Thanks, see ya.